In this scenario, we're going to look at a large cylindrical tank, and in this tank, we're going to see that we're dropping the water out through a pipe and onto the surface of a lake. What we're interested in computing here is the loss of potential energy of the water as it runs out of the tank to the surface of the lake. Well, this is exactly what we mean by the work done by gravity on the water. Gravity is exerting a force downwards, it's moving the water, and so work is being done in that process. As a quick test of the concepts, ask yourself, how should we choose the slices of the water for our integral? Of course, we're going to be building an integral for this, and the question is, well, how are we going to construct it? Think about the options down here for a moment, pause the video, and we'll check in afterwards. All right, so one tempting option is horizontal slabs, because in a previous example, that's what we did. Fair enough. The other two horizontals give us explanations. We'll go back to them in a second. Cylindrical shells, because the tank is cylindrical. That's a fair thing to think about. We might think about all of the water in a shell, and those are at constant radius from the center, and the drain was located in the center, so we talk about the amount of distance covered by the water going in towards the center. That's reasonable. Okay, well, reasonable apparently isn't just enough to cut it. Let's go back to our force times distance. And there's a subtext here, which is that the force is actually dotted with distance. So it's actually the magnitude of the force in the direction of movement. That's all that contributes to work. If we pull on something but not in the direction of movement, we're not doing any work. Well, let's actually turn that around a bit, because we know that the force is gravity. The only force playing a role here is gravity. So the only distance that matters, the only movement that matters, is vertical movement. Well, that gives us our answer. If the only movement that matters is vertical movement, and we take a look at our calculation about distance traveled, the only thing that matters is vertical distance. And as a result, if we're looking for constant distances traveled, if we need all the particles to travel the same distance, oh wait, the particles that travel the same distance are all particles that are in a horizontal slab. And that gives us answer B here. All the points in a slab are going to move the same distance in our force times distance calculation.